Okay, ozone. Ozone is a pale blue, highly reactive gas composed of three oxygen atoms. It occurs naturally in the stratosphere where it forms the ozone layer and absorbs harmful ultraviolet radiation from the sun, protecting living organisms from excessive UV exposure. So, ozone is triatomic allotrope of oxygen. It is an unstable blue diamagnetic gas with a characteristic pungent odor. It is much less stable than oxygen and break down in the lower atmosphere into oxygen. Ozone is formed from oxygen by the action of ultraviolet light and also atmospheric electric discharge. There is a layer of ozone in the upper atmosphere which absorbs harmful ultraviolet radiation from sun, thus protecting life on the earth. Purification of ozone. It is purified by silent electric discharge through pure, dry and cool oxygen in an apparatus known as Siemens ozonizer. This method produces only 10% ozone, and mixture of oxygen and ozone obtained by this method is called ozonoid oxygen. This is the figure, Siemens ozonizer. Silent electric discharge acts as ultraviolet light and decomposes oxygen molecule into oxygen atoms, which combines with oxygen molecule forming ozone. Ozone can be purified by heating oxygen over 2500 degrees Celsius and quenching. Low concentration of ozone can be made by UV radiation on oxygen. In all these preparation, oxygen atoms are produced and these react with oxygen molecule to form ozone. Higher concentration of pure ozone can be obtained by fractional liquefaction of the mixture. Physical properties of ozone. Ozone is colorless of slightly bluish air. Okay, ozone is pale blue gas or bluish gas with a characteristic pungent odor at minus 112 degrees Celsius. It condenses to form dark blue liquid, while below minus 193 degrees Celsius, it solidifies into violet black solid. It has characteristic pungent odor. It is slightly soluble in water and much more soluble in inert nonpolar solvents like carbon tetrachloride or fluorocarbons, where it forms blue solutions. Chemical properties of ozone. Decomposition. Ozone is thermodynamically unstable and decomposes to give oxygen. Decomposition is exothermic and also catalyzed by manganese dioxides, platinum black, copper oxide, etc. Formation of ozonide. Ozone adds to olefins and acetylene to form ozonides. which are decomposed by zinc dust and water to form carbonyl compounds, ozonolysis, action with ethylene, ethane reacts with ozone, forms ethylene ozonate compounds, and hydrolyzes into methanol. Action with propylene, also it forms propylene ozonate compound and hydrolyzes into methanol and ethanol. Action with acetylene, formation of ozonate compounds and hydrolyzed into okay. When ethane reacts with ozone, it forms ozonate compound and hydrolyzes into ethanediol. Oxidizing property, it acts as powerful oxidizing agent. Then molecular oxygen is important oxidizing property. For example, ozone liberate iodine from neutral potassium iodide solution. Next, oxidizing property, it oxidizes halogen acid, for example, hydrochloric acid into halogen. Hydrochloric acid produces chlorine gas. It also oxidizes potassium ferrocyanide to potassium ferricyanide. Similarly, ferrous salt is oxidized into ferric salt. Sulfide oxidized into sulfate, lead sulfide oxidized into lead sulfate. Potassium magnate oxidized, potassium permanganate. Nitrogen dioxide oxidized into nitrogen pentoxide. Stannum dichloride oxidized into stannum tetrachloride. Hydrogen sulfide oxidized into sulfur. Mercury is oxidized by ozone to form suboxides. It starts sticking to glass and loses mobility. As mercury loses its meniscus in contact with ozone, this is termed as tailing of mercury and used as a test for ozone. Reducing property, ozone reduces certain peroxides such as hydrogen peroxides, reacts with ozone, produces water, barium peroxide, barium oxides, silver peroxides produces silver. Structure of ozone, valence bond description of ozone. According to experiment evidence from the microwave spectroscopy, ozone is the bent molecule. The oxygen distance, bond distance are 1.27 at Armstrong, which is intermediate between single and double bond, and the oxygen angle is 116.78 degree. Ozone is polar molecule with dipole moment of 0.53 diopter. The bonding can be expressed as a resonance hybrid of the following two structures, producing an overall bond order 1.5 for each side. The structure of the ozone, molecular orbital description of ozone, central atom of the ozone, sp2 hybridization, ozone molecule, 4 electron, 3 central bond. Each oxygen atom is sp2 hybridized. The terminal oxygen atoms form sigma bond, central oxygen atom. The unhybridized pz orbitals of the 3 oxygen atoms undergo linear combination atomic orbital to produce 3 pi molecular orbitals, namely bonding, non-bonding, and anti-bonding. 2 electrons occupy non-bonding molecular orbital. The non-bonding electron pair do not involve in the pi bond formation, yet it is involved in the pi system. Only 2 electrons in the bonding molecular orbital contributes 1 pi bond over the whole molecule. In this way, total 4 electrons constitute the pi system, that is the ozone molecule involved 4 electrons, 3 center pi bond. The total bond order for each oxygen bond is therefore approximately 1.5. Uses of ozone. Ozone is widely used as a germicide and disinfectant. For example, it is used in the purification of drinking water because it is effectively destroys the bacteria and virus. Compared with the chlorine, ozone offers the advantage of leaving no unpleasant taste or odor, as any excess of ozone rapidly decomposes into oxygen, leading to harmful residues. Since ozone decomposes readily to keep the nascent oxygen, it is used as a mild bleaching agent for bleaching oils, ivory, flower, wax, and delicate fabrics. It is used manufacture of potassium permanganate, artificial silk, and synthetic camphor. It is used for detecting the position of double bonds in unsaturated compounds.